Hello students and welcome back to Geography 113. This is our tutorial walkthrough for tutorial 7-2, and I want to bring your attention to a few components. So once you go ahead and download tutorial 7-2 data, as usual, go ahead and open the 7-2 APRX file, but also notice that we have a PDF here, the topology rules poster. Go ahead and open the topology rules poster as well. We're going to use it to reference some of the topology rules that we're going to use. As you will see, this geodatabase topologies are more complex and extensive than the map topology. So I'm going to begin reading from page 225 for tutorial 7-2, working with geodatabase topology. So in the introduction, it states that you learned that map topology was useful for creating a temporary limited topology within a single map. Now you will look at the geodatabase topology. This type of topology is constructed against existing feature classes and stored in the geodatabase for use in multiple projects. Unlike map topology, geodatabase topology persists beyond the map in which it is created. It also it reads, so what are we going to do with this geodatabase topology? It can model the behavior of features represented as points, lines, and polygons. There are rules for like features such as polygon to polygon behavior, etc. In paragraph 3, it says that the first step in building topology is to determine what relationships exist in your data. Think about street networks, for example. One rule might be that each street segment should be drawn only once. And then paragraph after that says, after a set of rules is determined for a topology, you must gather all the feature classes that will participate in the topology and place them in a feature data set. So it is a requirement that all feature classes that are to participate in a topology, they must be in the same feature data set. And finally, the topology can be built. The geodatabase topologies are saved as independent item in the feature data set, and they can be updated later. You can add or subtract rules or layers to those topologies. And once the topology is built and validated, a new feature class is a new set of feature classes is created, and these special topology feature classes hold indicators of all the features that violate the rules that you have established. So basically we're going to do corrections. Each of those feature classes is going to point us to an error in the topology, and we're going to correct it, some by hand, others automatically. And then lastly, there's another topology rule that we have for cluster tolerance. The rule is called must be larger than cluster tolerance. And this is basically for edges that are pretty close to each other. The software does a pretty good job of identifying. It says discrepancies in the topology features will be measured in the thousandths of an inch, but will show up as a topology error. And on page 226, it says to prevent having to deal with minuscule errors, the cluster tolerance rules are mandatory for both lines and polygons. Vertices or edges that fall within specific cluster tolerance are determined to be coincident for purposes of the topology and will not display as an error. Okay. So in page 226, we begin the scenario. You work with the City of Olander parcel data in previous tutorials to design the geodatabase and perform some editing. In the future, you may be the one to maintain this data. So you will need to establish a set of topology rules that can help you with the task. And so this is how you maintain data. So the first step is to select the topology rules. I'm not going to go over all of these in this video tutorial, all of these rules. I'm just going to point out some of these. But on page 227, you also have a copy of this PDF of the ArcGIS geodatabase topology rules. This is a PDF, official PDF from Esri, and it tells you how to read these diagrams. And so if you're going to manage a geodatabase, specifically, let's say for something like property polygons or anything really, where you need to have some of these integrity rules of point, line, and polygon behavior. So how would we read this diagram? We identify a few of these items like point, lines, or polygons. All right. So each item is going to have its topology rule name and a graphic description. generalized description of when to use this rule, and then it's going to give you here a scenario description of a real-world application, and then here we have topology to topology, for example. So the topology rule occurs between two different feature classes or subtypes. When it only has one, it says the topology rule occurs within a single feature, right? So, for example, the must not have gaps rule, that this applies to polygons. Lines are in green, and there are a few rules also for points, right? So points are down here, line rules, polygon rules, and then there is line or polygon, and this is for cluster tolerance, for example, must be larger than cluster tolerance. Must not have dangles. So let's take a look at a few of these just so that you become familiar with what we're going to be using. Must not have dangles. Use this rule when you want lines in a feature class or subtype to connect to another, so that we don't have these. For example, in roads, sometimes we do not. These are connected. The endpoint of a line must touch any other part of another line or any other part of itself within a feature class or subtype. And so a street network has line segments that connect. That's one of those scenarios. The must not overlap rule. So if we read in page 227 in this paragraph here, it says the following suggested set of rules will ensure that property polygons have no gaps or overlaps, and that each property boundary is represented by a polygon edge. Okay, so it seems like these apply to what we are trying to do. It also ensures that some data integrity in the lot boundary line works. So these lines cannot have a dangling end, either an undershoot or an overshoot, and cannot cover each other and cannot trace back onto themselves. If you have ideas of other topology rules that you wish to use, add them to the list, etc. So we read the following list at the bottom of page 227. So for polygons, must be larger than cluster tolerance. So we do have this cluster tolerance rule. And this rule is applied to all line and polygon feature classes that participate in the topology. Okay, so we're going to add this rule a few times. We also have the must not overlap rule for polygons. Must not overlap is one of the basic tools. Polygons, so use this rule to make sure that no polygon overlaps another polygon in the same feature class or subtype. And this is pretty important because it explains in page 227 under must not overlap for the parcels feature class. You can't have overlapping polygons, or it would mean that two people own the same piece of property. Because we're talking about properties, the lines that differentiate two blocks are mutually exclusive for each owner. And then also the must not have gaps. Must not have gaps for polygons. So again, pretty basic. Use this rule when all your polygons should form a continuous surface with no voids or gaps. So this will point out any of those errors. Let's go to page 228. When we look at lines, we're going to use the must not be larger than cluster tolerance. So we used that already. Must not have dangles, must not overlap, must not self-overlap, and must be covered by boundary of. And then it says at the bottom of page 228, note that some of these rules apply only to a single feature class. So it says creating the topology and setting it up for use involves 4 steps. Creating the topology structure, adding feature classes to a topology, set a feature rank in the topology, and then after adding feature classes to the topology, add the rules. So we're going to build the topology on page 229. We begin this process. So we are here. We open our tutorial 7-2, and we open the geoprocessing pane, and we're going to search for the create topology rule. So FYI, there's different ways to do that. We can also just open the catalog pane. And since we're already working here with tutorial 7-2, and we have our geodatabase here, let's see if we can add a new feature class toolbox. Manage, import, feature classes. No, we're going to add this here in the property data. New. Yes, so we would add it here in property data, the feature data set. We could go to new and then do topology. That way, this is the topology wizard, and then we would add rules, and then we would do a summary So this is, I believe this is one way to do it, but let's just do it to the geoprocessing pane. So create topology. Create topology, so it's the first one. This is data management tool. And let's see if it has a similar layout. Oh no, this is actually going to be slightly different, it seems. But let's stick with it. Create topology. So input feature data set is property data. Within our 7-2 geodatabase. Property data, okay, and then set the input feature to property data, name the output topology all under underscore topology. So let's do that. Underscore topology, and for cluster tolerance 0.02. Okay, so we're going to search for and open the add feature cluster topology tool. Okay, so by the way, if this pops up here, it just basically tells you that this item named all under topology already exists. So if you're going to run this tool again, this is just warning you that you would need to create a new output topology name because this one already exists. But so we added this, and so here we have the all under topology in our under our geodatabase and feature class feature data set. Excuse me. So let's search for and open the add feature class to topology rule. Excuse me, topology tool, geoprocessing. Add feature class to topology. So we're going to set the input topology to the one we created in step 3. So we can note you can also use the browse button to select different criteria like the pane. So use the drop down arrow to set the input feature class to lock boundaries. Okay, so first let's customize feature process the source data for the partial polygons. Leave its XY rank at 1, then run. Okay. So first let's find our input topology, which is going to be set up and then the input feature class, lock boundaries, XY rank at 1. 1. Z rank at 1. So it says in the topology, each layer must have an XY rank and a Z rank, although we don't have Z data for 3D here, so that the Z rank doesn't matter, in which 1 is the highest. The layers with the highest rank will not be altered in an automated topology correction process. Layer with lower rank will be adjusted to be coincident with the higher rank layers. So here we're looking at lock boundaries. So lock boundaries are some of the most important layers in property data. Okay, so so we have added here lock boundaries. So all under topology, lock boundaries. Take a minute. And so here we have added our all under topology. And as you can see, there are dirty areas, point errors, line errors, and polygon errors that are going to be showing up. So in the Your Turn section, it says using the Add Features class of topology tool, add parcels. Okay, add feature class of topology rules. So here we keep all under, right? We're going to do parcels, and we're going to give parcels an XY rank of 2. And then we're going to add blocks with a topology XY rank of 3. Okay. So it says here this was completed correctly. So in the your turn section, it points us to the Olander topology here in the feature data set for property. And when we look at its properties, right clicking on it, feature classes, it tells us which feature classes are participating in the Olander topology and which one has the highest rank. So the lot boundaries is the one that's not going to move, but parcels and blocks are going to change. It's, so we're now in step 6, search for and open the add rule to topology. Okay, so let me click out of here, and then we're going to add rule to topology. And in the add rule to topology dialog box, we're going to set the input topology to Olander, of course. So Olander. So here, these are some of the rules we're going to add. We're going to begin. So in the input topology, then set the rule type to must not overlap area. Must not overlap area. Must not overlap area. And then for the input feature class, it's going to be parcels. We're going to run this. On page 231, it says, note that there are 2 places to enter a feature class name. In this instance, only one feature class was entered, which means the polygons of this feature class cannot overlap themselves. But if a second feature class was entered, it would apply this topology rule across both feature classes and not allow them to overlap each other. Okay, so here we could also see other options. On step 8, it says, when the process completes, reconfigure the tool to add must not have gaps to parcels. Then click run. So let's look for must not have gaps. So must not have gaps area. So it was just right above that. Apply it to parcels. Click run again. It says note that this is a self-protection rule. It will keep polygons within feature class from having gaps. So we're going to change the add to a rule type must be covered by feature class of area. Must be covered by feature class of area. And we're going to set it to parcels with the input subtype of platted property. And then set the second input feature class to blocks. Second input feature class. It says this rule acts on both feature classes to make sure that blocks can exist only when there is a parcel. Further, by adding the subtype value, it says that blocks can exist only where there is a platted parcel. Because some platted property doesn't have a block designation, leaving out the subtype reference would mean that all platted property violates the topology rule. So this is to make sure that all parcels have property on them if they are platted. Step 10, it says in the catalog pane, open the properties for the Olander topology, click on the rules tab to verify all 3 rules have been added, and then click OK out of the dialog box. So let me just close this here. We'll go to Olander topology, properties. We'll go to the rules added, and so here we can see the rules, feature class, rules does not overlap, subtypes, etc. Okay. And so here we can also add, it seems, more rules. So we are now on page 232. It says this dialog box also has tools that let you add new rules, remove rules, save a set of rules, or load a previously saved set of rules. So if you have already designed a topology in the past that works for your projects, you can just import that topology. So if you create a good topology from the beginning, and you like the rules, you know how those rules work on your polygons and lines, etc., then you can just keep that, okay? So this is an advantage of knowing the rules of topologies, because there will be projects where you are managing large data sets and you have to keep point lines and polygons from overlapping or from having gaps, etc., or covering other areas. So it says that topology properties pane also displays general information about the topology, including its validation status, the feature class involved in the topology, and the errors. Okay, so we're going to do a your turn. It says add the following rules of Voyager topology. Use either the add rule topology tool or open the topology properties pane, highlight the rules tab, and use the add button to add rules. So we're going to stick with the, I'm going to stick here with the properties topology, and I'm just going to add a rule to feature class 1, and then it says, when you're finished, view the topology properties and verify that all 8 rules were added successfully. Save the rules to the project folder for future reference. So save the rules to the project folder for future reference. Okay, so here we see we have 3 for parcels, 1 for blocks, and 4 for lot boundaries. So we already added the 3 for parcels. Let's click on add then. Okay, so here, click here to add a new rule. Okay, oh, so we already have one here. Okay, so we're going to apply this to blocks, and the rule is must not overlap area. Must not overlap area. And then we're going to do lot boundaries. Must not have dangle. Must not have angles for lines. We add for lot boundaries again. Must not overlap line. Must not overlap line. We also do lot boundaries again, and we add must not self-overlap line. We add one more for lot boundaries. Must be covered by boundary of line area. Must be covered by boundary of line area. Okay, so let's save as. We're going to save it here to our project folder. We're going to save it as topology rules. Okay, so it says the final step in creating topology is to validate it, which will check the existing data against the new topology rules you created. So this is at the bottom of page 232, by the way. Again, it says the final step in creating topology rule is to validate it, which will check the existing data against the new topology rules you created. This first time, though, there will be a lot of topology errors that must be fixed. In the future, you will have to fix topology errors only after editing, so there will only be a few errors. So every time that you edit a large section of your geodatabase features, that's when you would ideally also want to run a topology more thoroughly. But after every editing session, you can also run a topology to make sure that there aren't errors. So at page 233, it says the validate topology will by default run the validation checks on the current display extent. Anytime you want to validate an entire data set, you must assume the map to its full data set. Okay, so let's first of all click OK here. So we are adding our rules to our topology, and we're going to take a look in a minute. Okay, right, so the topology rule is invalid or malformed. Interesting, we have an error, which specifically, so we got that error. Let me go back here. Okay, that's good to know. Okay, let me go back and then look at our topology rules and see which one might have been an error, but it seems like there isn't a solution for that issue. These are our properties. Let's go to our rules. See our errors here. So here we're going to generate the summary. 1, 2, 3. Oh, I'm missing. I might have been missing then block boundaries. must be covered by boundary of. Is that the one here? Parcels, blocks, block boundaries, block boundaries. Must be covered by boundary of. Line area must be covered by boundary of. Line area, I'm pretty sure this is. Okay, got it. And then feature class 2 is parcels. So it was good. I caught me in that error here. Okay, got it. So let's look at that again. So hopefully you didn't get that, make that mistake. Okay, so if you did, we fixed it. We are now going to validate the topology. So let's zoom to the map full extent. Okay, that's too far. Let's go to the layers here. Okay, this is better. Okay, so here we're going to generate our topology. I have any bookmarks here? No bookmarks yet. Let me save our progress while we're here. And also, I'm going to just create a bookmark. Good to get in the habit. Then say full map as well. Customize quick access toolbar, customize the server, minimize server. Let's see. Properties, extend, use custom extend, current visible extend. Here we go. Use nothing. That would be full extent. Okay, good. So we're going to begin to examine the line errors. So we're going to find and run the validate topology rule using the Ollinger topology for input. Okay. Validate topology. Ollinger. Click run. Okay, so the areas that it's pointing out here in pink are errors. There's also a few exceptions, right? So as you can see, there are a few errors we're going to have to correct. On page 233, it says, when Ollinger topology was created, a special group layer was added to the contents pane, right here. It contains topology feature classes to show and identify topology errors. The dirty areas are layers, the dirty areas layer here contains, where am I? I've lost it. The dirty areas layer shows places where corrections to the topology have been made and need to be revalidated. The other three topology layers show features that are contributing to the error. The goal is to examine every error and either fix it or mark it as an exception to the rule. These tasks seem long and tedious, but once your data set is topologically perfect, the only errors you will have to deal with are those introduced in new edits. And with care, those can be kept to a minimum. Okay, so let's say that we have just created this topology. We're going to need to run a major edit like this one. But in the future, as it says, you will only have a few errors after you do some edits. So you want to keep those to a minimum with good editing practices. And so we're in step 1 of the examine the line errors on page 233. In the contents pane, turn off the parcels, blocks, and polygons and polygon error layers. This setup will allow you to concentrate on fixing the linear errors first. So let's turn off parcels, blocks, and polygons. Polygon errors layer. I'm going to turn off blocks, parcels. Okay. So we're only going to leave point errors and line errors. Okay, so click the Edit tab in the Manage Edits group. Edit. to map topology. Oops, sorry about that. So it says here, click the edit tab, manage edit groups, drop down which topology select in the geodatabase. Oops. Okay, so this is where we're running these edits. It says step 3, also in the Manage Edits group, click Error Inspector to open the Error Inspector table, from which you will manage corrections. Let me just reduce this over here. From which you will manage corrections. Make sure the filter button for the map extent is not checked so that all errors will display. Then click to examine the first few errors. You can click in the preview area and zoom out a little to get a better view of the errors. Okay. So let's click on the Manage Edits group. So, and then let's click here on Error Inspector. Okay. So there's going to be this this table with the errors that opens down here. Let me just close this to across the screen for now. Right, and here we have preview, fixes, etc. All right, and so it has registered 28 errors altogether. Okay. And so it seems like sometimes it'll seem like a lot, especially because we're also doing polygons, etc. But as you will see, this goes by pretty fast. Once you get a hang of it and you are able to correct a few errors, we can use some tools for the software to correct a lot of errors automatically. So it's not going to be as time-consuming as it seems. Okay. Let me just save while we're here. Okay, so let's keep working here then. We are here in the Error Inspector. So it also tells us here in the Error Inspector, it says, make sure that the filter button for map extent, it's not checked so that all errors will display. Okay. So this is not checked. Then click to examine the first few errors. You can click in the preview area and zoom out a little to get a better view of the errors. So let's take a look at a few of these. As we click, okay, got it. So here we get some lines like these. And we click on them. For details, fix. Okay, got it. And so here we can do either mark as exception or clear exception or delete feature as well. So where is this? Where is this feature here? It's not showing up in cyan, right? So this is an interesting feature here. Let's go back up to reorganize that. So that's for parcels. Okay, got it. That's for the whole. Must not have gaps. Okay, got it. So whenever we click around, there's a few that show up. Okay, and boundaries. Oops, like that. Okay, let's not overlap. Interesting. Then here we get a preview of those. Gaps. Okay, let me just close this for now and then open the Error Inspector again just to see where it takes me. Okay, so here we have these 11. Okay, so let's go now to page 234. So we have our Olander topology. And it says the Error Inspector table displays all the topology errors that were found in the data. Let's zoom out to the whole map. That way we get to see all the topology errors. Right? There should be 280 of them here. So again, let's read on page 234. The error inspector table displays all the topology errors that were found in the data. You can show all the errors or just a subset of errors. Each error can be selected and will be displayed in the viewer on the right of the pane. Clicking the fix along the top of the viewer will present several automatic fix tools for the error. Also, along the top of the viewer are tools that will let you restrict which type of errors are shown and validate the topology once corrections have been made. You will start with the must be larger than cluster tolerance error, since these errors can all be marked as exceptions. These errors are segments that are smaller than the cluster tolerance, but are not errors in how the data was drawn, so they are all right to keep. Okay. So at the top of the inspector, let's click the filter here, and in the resulting list, clear the checkbox next to show exceptions. Must be larger than cluster tolerance. Okay, must be larger than cluster tolerance. It says on step 5 of page 235. If you want to get a feel for what these errors are, click on a few of them and see the features that are creating the error. When you are finished viewing them, select all the errors on the right side of the viewer, and then click Fix, and then click Mark as Exception. Okay, so let's take a look at some of these. The cluster tolerance. Okay. Must be larger than cluster tolerance. Got it. Okay. So let's select all of them. Then it says, and we're going to fix and mark as exception. When you are finished viewing them, select all the errors. So I have 35 of them. Let's scroll down. Press Shift. Or sorry, let me just do 35. Scroll up. See if Control. No, it's going to be Shift. Yes, correct. So it's Shift. So I have selected all of them. Oh, okay. Just copy, so I can do Control A for a select all. Alright, so 35 of them are selected. We'll fix. And we're going to mark as exception. Okay, and so now we see here this green exclamation point. It says all errors are corrected as a batch and disappear from the error inspector table. For the other error types, the error inspector tool may give you options to correct multiple errors at once. You may need to extend a line to meet a boundary, trim a line that has gone past its boundary, or snap the end of a line to a boundary. There may also be circumstances in which the lines are drawn correctly, yet do not need to touch the boundary. So we're now going to change the filter to lot boundaries. So change the filter to lot boundaries, must not have dangles. Lot boundaries must not have dangles. Select a few errors and then click the Preview tab to see the issue. You will see that the lines either fall short of the intended snapping target or run past it. So let's click on a few features here. Let's do Preview. Okay. Interesting. Okay, so let's take a look at some of these here. Okay, guys, so there's all these dangles here that were okay. So select all the errors on step 7. Select all the errors and click the Fix tab and select the option to extend with a maximum distance of 10 feet. Let's click on Control A. We're going to go to Fix, and then it says here, click on Extend with a maximum distance of 10 feet. 10 feet. Press Enter. 12 of 22 features extended. Note, if you get an error, the lines cannot be fixed. Make sure that they are available for editing in the List by Editing tab on the Contents pane. Okay, so we didn't get the error, so this worked for us. For number 8, step 8 on page 236, it says, repeat the process for the remaining must not have dangle errors, except this time use the trim fix at 10 feet. So, must not have dangle errors. So here we have must not have dangles. Control A. So for these, we're going to trim at 10 feet. Click Enter. That also corrects these. Okay. So in the Contents pane, turn on the Dirty Areas layer. So we're now in step 9. On page 236, the fixes that you applied will have modified the features, so save the edits before continuing. Okay, so let's go to Edit, and then let's save our edits. This is a good reminder. What we're doing here, we are editing features as a whole. If they violate these rules, so we're still in our editing session. Let me just close the. Let me just reduce the error inspector briefly here. So for step 10. In the Contents pane, turn on the Dirty Areas layer. Okay, got it. So this is the area that we've been working on. Blue polygons are shown. Blue polygons are shown around each feature that has been corrected using the error correction tools, but has not yet been validated. These blue areas, known as dirty areas, show areas where features have undergone some sort of change since the topology was last validated. When you turn the validate process, it matches those areas against the topology rules to make sure that the changes both solve the former error and do not unintentionally create new errors. Step 11, on top of the error inspector table, click Validate. So let's go to, so here we are, error inspector table. Let's click Validate. Okay. For these errors, the Error Inspector tool presented 3 suggested methods for correcting the errors. The solution was to try to either trim, extend, or snap until they intersected, or mark them as an exception. This is the same task performed by the extend and trim tools, except the topology rule allows the corrections to be done in a batch process that it corrects all the lines at once. It's advisable to try to correct the error with the trim and extend tool first. These tools will modify only the feature that is reporting the error. The snap correction, however, may move either adjacent features that are not currently used, causing the error. Next, you will try an interactive error fixing tool. At the bottom of the error inspector viewer is the error correction tool. Okay, so as it says, this is a more interactive way to fix, which is located here. So it says, selecting a topology error will present a pop-up menu with possible fixes. Note that this is a one-at-a-time method as opposed to the batch method used before. All right, so let's change the filter rules to lot boundaries must not overlap. Lot boundaries must not overlap. There we go. And let's select the first error in the viewer. So here we have 9 in this batch. Let's select the first one, and it brings us in the preview, brings us to this area here. And select the first error in the viewer. It will be highlighted in yellow. In the pop-up box, click the remove overlap. Okay, so let's select it. Okay, got it. So I clicked it here, and then once I clicked on it with the error inspector, remove overlap, and then pop-up boxes. You are then prompted to decide which part of the line to keep. Clicking each choice will highlight the segment in the lap. Select the one marked largest and click remove overlap. Got it. Okay, so the largest one is doing, this large one is doing the overlap. Okay, so we select the largest and remove the overlap. Okay, so it says at the bottom of your turn, continue through the list of must not overlap errors and use the error correction tool to remove the overlap. You can use the zoom tool to find the error in the map. If the dirty area layer is still visible, you will see the polygon, you will see the blue polygons pop up as each error is made. When you're finished, validate the topology and save the edits. Okay, so this is a good time to save also for where we started. Let me also save my data here for this project. And so we're going to do must not overlap errors for this one. And then later on it says we're going to change the filter to rules must not self-overlap. Read the choices. So first let's work through these then. Okay. So here it takes me to this one. Click on it now. Remove overlap. Interesting. Let me extend this so I can see this better visibly. Interesting. Let me go to this one. Did I accidentally do that? I don't have this timer going on. Here, okay, got it. Okay, let me just pause here for a minute. Okay, so for this your turn section, we're going to be working through the lines. So let's just go one by one, right? So here we have our, make sure that we have the error inspector turned on. We also have the zoom to error tool, right? So the zoom to error tool will allow you to zoom to that area. And so we are doing the line must not overlap. So let's click on this one here. Click on it, remove overlap. And so you can expect, so this boundary is okay. This large one is the one that is overlapping. So we remove that overlap. So we continue with this one. Again, let's go to the error area. Remove overlap. Now let's see which boundary is overlapping. Interesting. Let me zoom to this error. Okay, got it. So this seems to be the correct error area. When I click on it now, move overlap. Census here. Okay, got it. I see. It's sending us there. A very specific portion of it. Okay. So let's go zoom into it again. Just click on it, remove overlap. I am going to take the largest Okay. So for this your turn section, it says at the bottom, let's take a look at here. So you're going to continue the must not overlap errors for lines. And you can use the zoom button to find the error in the map. If the dirty areas layer is still visible, you will see the blue polygons pop up as areas corrections are made, right? So this one here, this correction is made. So we do want to leave dirty areas for now. That's what happens. That's why this turns blue. So let's go to the next one. Click on this, remove overlap. Let's just read briefly which one is overlapping. So it's this one. Let's remove the overlap for this line. So this dirty area here. Let's click on the next one. The must not overlap tool. Let's take a look here. Okay. Let's just expand. Oops. Let me just bring this back to where we were, but I want to have a little more space for the map. So let's just continue doing looking at all of these. And removing overlaps. So this one is overlapping at the top here. So remove that. Similarly for these. Once we finish the lot boundaries, once you finish this section, we're going to then change the filter to rules must not self-overlap. So filter so must not self-overlap, excuse me. So this is for lines, lot boundaries, must not self-overlap. Right, you will see a few of these other errors as well. And then once you finish correcting for lot boundaries must not self-overlap, it must be covered by boundary of. Must be covered by boundary of parcels. Okay. So these are 12 errors here to select. So these are you're going to resolve on your own. And then it says at the end, as the final check that show errors for all rules. So at the end here, we're going to do the show errors for all rules. And make sure that there are no errors for lot boundaries layer anymore. Okay, when we do show errors for all rules, lot boundary layers should not show up anymore. You should see parcels, okay? So make sure to finish this section on the your turn. And by now you have seen how we make these topology corrections. In the next section on page 238, you will examine the polygon errors and make those error connections there as well on your own. And make sure to complete the your turns sections. We're almost done with this tutorial, but you should now be able to fix the rest of the errors on your own. Just make sure that you look at what overlaps and what violates the rule, pan around, and pay attention to the instructions closely as you finish this this portion of the tutorial. Okay, the software is going to keep on showing you some of these tools that you can use to resolve problems in a whole batch. So maybe there's about 20 minutes left, 25 minutes left to this tutorial. Okay, so make sure that you go to the Canvas instructions there to see what you're going to turn in, but it's basically going to be a map showing the entire structure here, always remember to save your edits. So it's going to be a map showing the entire structure here without any of these errors. So errors should not be in red anymore. Okay. Okay, that's it. Good luck, and let me know if you have any questions.